Okay, let's do this here. I want to call this general factoring. One, take something out. Two binomials. Oops. Difference of two squares. Trinomial. Says either guess or AC for grouping. So there's our factoring methods, correct? All right. So what we're going to do on 6.4, actually all these sections except for the last one are all pretty much the same thing. All right. So 6.4, they have you, they call to a couple different special polynomials, I guess. All right, and if you can recognize them and factor them, I guess that's okay, but I don't really know if it's that crucial. So I'm going to just show you them, and then you can factor them however you want. All right, and then after that, it's going to be some real general type of factoring, which again, it's pretty much the same thing, except it's going to be more like 2 or 3 step factoring. So those would be those first. That's going to be 6.4 and 6.5. All right. So, take something out as we already did. Trinomials, guess, or AC we already did. Grouping we already did. The only thing we haven't looked at is number 2, which is the difference of two squares. All right. So, here's what is kind of important if you're not real good with squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. All right, and I'll put a couple more on here because they show up also, but not as much. All right, so this would be like your number, and this would be like that number squared. Okay, so if you know your squares, then you're in good shape with differences of two squares. If you don't, then you might want to have this chart or something handy so that you can tell what a square is. All right? So you understand what I'm saying about where these numbers are coming from, right? You know?
Yeah, like the 4 times 4.
Right. 3 times, right. Okay? So we're going to use this chart, if you need to factor what is called the difference of two squares. So a difference of two squares looks like this: x squared minus 4. So this is a perfect square, and this is a perfect square, and this is a minus, which we would say is a difference. All right? That's why this is called a difference of two squares, because both of these things are squares. It doesn't always have to be two terms. It might be in a different form. And I don't know if you had some of those, but I can show you. But they're called a difference of two squares. Here's how they factor. This is going to be x. This is going to be x. 4, 2 is my square root, or my number that multiplies to that. This is going to be a minus, and this is going to be a plus, and that's how those factor. So you're always going to have a couple of things. One, these two things have to be squares. This has to be a minus. when you recognize that, it's always going to break out to x and x, 2 and 2, minus and plus.
So you said that the 4 has to be square.
The 4 has to be a perfect square.
Oh, a perfect square. So it could be like 6 or 8 or whatever, but it has to be like a solid number.
It can't be 6 or 8 because 6 or 8 is not a perfect square.
Oh.
It can be 1, 4, 9, 16, 25, 36, all the way down. Okay? And if you FOIL this, notice what you end up with, right? Because factoring is just unfoiling. Right. So let's try another one here. Okay, again, this is a difference of 2 squares. Obviously the x squared. So that's going to drop down there. And what's the square, what 49? So what's that going to be as a square root, kind of? 7. And one of them's got to be a minus, one of them's got to be a plus.
So does the plus and minus matter on which side it is?
Nope.
As long as it's in 1?
Mm-hmm. Okay, so we'll try some more here. Yeah. How about we try x squared minus 25? So what's that going to break down to? 5. So x minus 5 and plus 5. Again, it doesn't matter which order you write it in.
So if they're on the table of the square, right?
Mm-hmm.
We're just going to, it's basically putting down the x's and then adding one side minus one side addition, and then whatever the perfect square is. So if it's like 36, we put 6 on both sides.
Yep. Difference of 2 squares. Okay, we'll ramp it up a little bit here. Four x squared minus 81. Again, this is a difference of 2 squares because we have an x squared, we have an 81, and we also have a 4. So what is this going to factor down to? See if we can get it. 2x minus 9.
2x plus 9?
2x plus 9. Yep. Let's see. There's another one. Difference of 2 squares. Four x minus 1. 4x plus 1. Yep. That's the difference of 2 squares. Want me to show you where a lot of people make mistakes? Okay, I will. Think it's right? You just did what? 6 difference of 2 squares. It's gotta be right, right? Watch what happens. What's that equal to if we FOIL it? That. 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 So is this going to be the same as that? No. So see, you got to be careful because just because these are squares, just changing that to a plus doesn't automatically mean you're going to get this. Okay?
So it always has to be minus.
Always has to be minus. Okay? Always has to be minus. You can't even factor that. It's not factorable. So be careful, all right? Because this is going to add up to 24. It's going to give you a trinomial, all right? So you got to be careful with that. But there's a lot of people who just, you're doing the difference of 2 squares, you're used to doing that. You see those 2 squares and your mind just goes automatically to something that looks like this. Okay, so be careful. The other things that is in that section, I'll show you. And they're going to be trinomials. And they're going to say, but they called the, by the way, this is called a, I'll tell you what it's called. It's called a trinomial square. Okay? Not that I'm ever going to ask you, and no one's ever going to ask you about it. All right? But that's what it's called. And what I would do with it, if just saying, I would just factor it as a trinomial and not worry about the pattern that emerges. But if you like the pattern, then you can do it. But for me, I think it's just easier to just say, I'm just going to factor this like a trinomial. So if we factored it like a trinomial, we're going to take factors of 25, which there's not very many of, and what's it going to have to add up to?
10.
So 5 and 5. So x plus 5 and x plus 5. And in the back of the book, they might write it like this. Okay? They might.
So which way is the correct way? Both?
Oh, as far as which way to write it?
That you
Either way. Doesn't make any difference. Let's try another one of these. What's our answer going to be?
3, 3.
Mm-hmm. And then we'll do one more and we can talk about the pattern here. I'll make this one a minus just. What's it going to factor to?
X minus 7, then x minus 7.
Yep. Okay. So. Oh, I didn't quite get that top one. So let's look at some similarities. There we go. First of all, what do you notice about these last numbers? They're squares, right? Okay. And what do the always factor down to? Yeah, that square root of that number, right? Okay. They always do that. So, when this is a perfect square, and it just so happens that the square root of that, doubles gives you that. then that's what it is. But really, I just factor it like a trinomial. It's just one less thing you got to worry about. Yeah, just factor like a trinomial. Okay. Let's see. Yeah. Questions on those ones? So now we have all our strategies. That's it. Difference of two squares, trinomials, taking something out, grouping. We got them all. So then what we're going to do is take those and use them on different ones. So on your test, when it comes to factoring, all I'm going to say is factor completely. So then they're going to give you, and you get to figure out which method you're going to use. To factor it. Okay? So for example, let's say we have something like this. We'll do some of these and I'll get you a break. So, factor completely. All right? Now some of them are just going to be done with one step. Some of them are going to be done with 2 or 3 steps. But what you want to do is go right down that list. Okay? So when you're doing these problems or you're doing a quiz or test or whatever, it's the first thing you do. Can I take something out of that? I really don't think there's an E in here. I don't know what I'm doing here. Can I take something out? So can we take anything out of that?
The 7x's.
7 and x. All right? So once I take something out of that, then I go, okay, let's see, what have I got left? Well, I have x. What would I have left here?
1.
X squared minus 1. All right? So I go, okay, good. I took something out. I got that. All right? Now, you don't want to quit, though. You want to go back through that list. So we took something out. Check that off. The thing we have left over, that's this right here. Okay? Is it any of the remaining things? Is it a difference of 2 squares?
Yes.
Yes, it is. Because x squared minus and 1. So it's a difference of 2 squares. Okay, so now I'm going to put this 7x out here. So don't care about it. I'm done with it. And I'm going to factor that thing like it's a difference of 2 squares. Now there's nothing more for me to factor. I can't do anything more. So this is done. But when you're factoring this, always ask yourself, can I take something out? Is it a difference of 2 squares? Is it a trinomial? All right? And chances are you're not going to get a grouping thing, but you might. All right? Those are the things you should ask. Almost every single time you'll be able to take something out. Okay? Almost every single time. All right, let's try... Okay, we'll do one like this now. First thing I'm going to ask, can I take something out?
Yes.
Yep. What can we take out? 2 and
X.
x. All right. I have an x in each one of them, so I'm going to take that out. Parentheses. Now I'm going to divide that out of there, so what are we going to get left over here? 12? Well, hold on. X squared minus 12x plus 36. Okay, so now I go down my list, check something out, I'm done with that. Do I have a difference of 2 squares left over?
Yeah. X squared and 36.
Well, what about the 12?
No, there's no perfect square.
Well, there's perfect squares, but is it a difference of 2 squares?
No.
No. Remember, 2 squares has got to be 2. 1, 2. Okay? And we got 3 terms in there.
Yeah.
All
So
right?
then all 3 have to be perfect squares for it to work then?
Okay, well, let's just make sure, let's clean up our terminology a little bit, all right? So if we go back up here, so these are differences of 2 squares because there's 2 terms, right? Okay? And 2 only, right? This has a square in it, 36, right? But there's 3 terms, x squared, 12, and 36, okay? All right, so that differentiates it out. All right, so what is this thing inside here then? If it's not a difference of 2 squares, it is a?
I did the AC method.
You did? Okay. What is, so that means that what is it though? It's a trinomial, right? Okay, so, all right, how do we factor trinomials? Well, you know, we use the AC method or whatever. I probably wouldn't use the AC method on this because I don't have anything in front of the x squared, right? You see that, Kyle? See, we don't have anything in front of the x squared. I don't need to use the AC method. I got to find factors of 36 there to give me 12.
66.
There we go. So that's done. Okay, so when I'm doing these, I'm looking to take stuff out and then going down that list. Just keep going down that list. Is it a difference of 2 squares? Is it a trinomial? You got to recognize them though and know what they are. Oops. It's taking me a while to make these up. Where's my... Oh, there we go. Okay, here we go. I knew I could do it. There we go. Okay. Write down our list. What should we do first?
Take something out.
Yep, what are we going to take? 4? Good deal. What's that going to give us? Okay. Okay. Next on the list, what should we check for now?
Is there a difference of 2 squares?
Is it?
No.
Nope.
Is it a trinomial? Yes.
Yep. What method do you want to use to factor if it's a trinomial?
AC, I always just do AC.
AC. Everybody's liking the AC. Here we go. Okay, that's going to give me a 6 then.
It gives you -6.
So there's my factors. Which ones work?
2 and 3.
Man, 2 and 3 is very common mistake. People say 2 and 3 a lot. Okay? Because 2 and 3 add up to 5, but you see this minus here? That means these have to do add or subtract to 5. And subtract, huh? Yeah, 2 and 3 is a very common thing to do there. Okay, so which ones do we want? 6 and 1. Okay, I don't know why this thing's like predicting my, or I do stuff and it makes a shape out of it. So now I get 2x squared. Let's see, I think I'll go with, what is it?
-3x.
Where're the negatives? Hold on. I thought we were doing AC method.
Yeah, when you put the 2 and the 3 down.
But we just said 2 and 3 don't work.
Oh.
Because it's minusing the 5. And 2 and 3 subtract.
Oh, okay.
Okay. Very common mistake. See, it's already been made. Here we go. So what numbers are we using?
6 and 1.
Okay. So we're going to have a 6x here and an x here. And what am I going to put in front of the negative or in front of the 6?
Plus.
Plus and negative.
Better be a minus. Because we got to get a -5. We won't get it if we put a +6 there. All right. Slow down and think about what you need to do. Okay, we really don't need to worry about the 4. All right, so I probably won't even mess with it. I'll just kind of leave it there for now. Because I know I got to group this. So what can we take out of the first bunch?
2x.
There you go. And what are you left with?
X minus 3.
Good job. Plus, what can we take out of that? Ooh, look at that. What are we going to take out of that one?
1.
1. Can't do anything else. But we got to have something, or else we can't factor it. Okay. So what's this going to look like?
4, 2x plus 1.
Good. The 4 is going to pop back in. 2x plus 1. Good. And
X minus 3.
x minus 3. So always make sure you check to see if you can take something out. All right. Okay. Let's take 5, 10 minute break, whatever. And we'll do some more of these. I'll show you some tricky ones. Hi.
Next week, they want to do so I have to either way, but I have to be at 10:30. So I can come in at 8 and at 10 to get back to
Yeah, do what you gotta do.
I'm in a pineapple program and I can't.
Yeah.
So
Okay, then.
yeah. So I'll come in at 8 and I'll leave at 10. So if I can do my quiz or anything.
Like this time?
Yeah, you can do it then, or
I
you
guess
can
it's
always
hard
do
to
it.
do.
I mean, you have till June something to do them. Right. It's not real crucial. You're probably actually better off to get the
Yeah, because I
yeah,
have to be there
it'd be,
at 10:30.
oh, yeah, you leave it. So,
Yeah, because they don't close late on Saturday. That's why.
yeah, see, I mean, we're breaking now, so we'll have, you're probably best just to get the instruction once again, rather than taking that quiz, I think.
So
It's probably
just do the
better.
information and then we'll arrange.
You know,
for it.
we'll just figure something out. I mean, if the worst comes to worst, we can always schedule to the testing service. I mean, it takes you 5, 10 minutes, or not even longer, but do you do it during the day?
I don't work on weekends, but
During the day, during the week?
yeah, I work Monday through Thursday. Yeah, I go to class Fridays at 10 to 1.
We can check to see if you know, I can figure something out,
Yeah,
maybe. If you're up here on Fridays, the
Yeah, I'm
testing
here.
service isn't open on Fridays. Sometimes they'll let people go into the math office and do something. You can always drop in there too, maybe we can get it.
We'll figure it out in a minute.
And we'll figure something.
Yeah, thank you.
Yeah.
Okay, just wanted to let you
Oh,
know.
yeah, thanks. Wasn't here? Where was that? That's no good. Oh, here they are. Is there no staples in there? Can you get it?
No.
No staples in there? Okay. I'll go get some. Oh, you're okay.
Logical? Yeah.
Okay. If it's logical enough, maybe you buy it.
Yeah.
Thank you.
So how many coaches are there in the track?
In middle school track?
Just one?
For us? Oh gosh, no, we had 133 kids. So, that'd be a nightmare.
So do you have like one for like shot put and then one for running and then, or is
For middle school, for us, there was 4 of us, but there was 4 of us. So like I do all the throws, and then one guy does the distances, and then we have our head coach is a gal. She does the jumps, and then like the long jump, and helps out with the sprints, and then the other her husband does the hurdles and relays.
So when do they start introducing that, the one that you like jump over the stick? I don't know what that
High
is.
jump.
Oh, so in high school?
No, we do that in 6th grade. Yeah, our 6th graders were off doing, yeah. Not run and jump. You're talking about just over the bar, right?
No, I'm talking about like the running jump.
Not with a pole?
Yeah.
Oh, that's high school.
They
Pole vault, they don't do that till high school.
Or is that like every high school, or is it just like?
Mm-hmm. Yeah. Now that's different. Now in high school they have, see then there you have boys, usually coaching, girls kind of coaching thing, but, so we had, let's see, that guy, jumping coach, you see Pat, and Kyle does throws, Naomi did distances, and Neil does pole vault. There's 5 of them in the high school, and probably, Megan, so 6. I think they have 6. Right. That's us. Some schools are going to have more, because they have more resources, you know. I mean, for example, like for us, Wilsonville is in our league, now they're going to have more coaches and more resources because they have more money. Yeah.
I live right there. We were thinking about buying a house in Wilsonville. Didn't do it. Now I'm like, man, we should have done it, but.
Yeah.
I think you say that, when you buy that home, and then the school's kind of like,
Holy cow. Okay. Or did I pause it? No. Hey, let's do this to start off with here. If you would go back to, I want to show you this. Where is it at? I saw it. Oh, it's not there, sorry. 6.4 is the section it's in. There it is. 447. Oh, guess it is writing up there. All right, 447, sum and difference of two cubes. All right, I don't spend a lot of time on this, but the author who wrote this book has a number of sum and differences of two cubes in here. So it's probably worth mentioning. I don't know who you're going to have for your next class. They probably will expect that you've kind of seen this a little bit before. But I'm not going to test you on it, okay? So here's the formula for these. I want to make these little letters because it seems a little bit more appropriate. That's that one, and this one looks like this. So, just like squares, there is cubes also. So when you recognize that, you use these little formulas for it. All right, and again, I'm not going to test you on it because you have to memorize the formula. And they just don't come up very often, but whoever wrote this book kind of likes them. So I'll show you an example or two, and then probably wouldn't be bad for you just to do a few of them in your assignment just so you know how to do them. So for example, here's one. Now 8 is a perfect cube because 2 times 2 times 2 is 8. All right, and we can add cubes to the chart if you want to. It's not a big deal. We can, but here's how this is going to work. So x cubed minus 8 follows this one. So this says you would take the, like whatever this is, to the third. So x would go here.
But how would you know that? Oh, because of the subtraction.
2 is going to go there because 2 cubed is 8. Then we're going to take this first term here and square it. So it'd be x squared plus, then you're going to multiply the 2 and the x plus, and then a 2 squared would be 4. And that's what that looks like. So you find the two cubes, and then you know the x is whatever that is cubed, or the cube root of it, however you want to think of it. X and x squared. And then the 8, the cube root of 8 is 2. So we'd have 2 here, and then you square it. So here I can do another one.
Okay, so I'm a little confused. I
Mhm.
I understand how we did the x, but the second part was this 2x.
That's just in the formula. Oops. So here where it says take a times b, like that. All right. So the a in this case is the x, all right, and the b is the 2.
Okay, then you just put it together.
Yeah, you just multiply them together. So in this case, again, this is obviously going to be x. This is going to be plus. And then we just need to know, well, what cubed is 27? 3 times 3 times 3 is 27, so that would be a 3. And then we'd have x squared there. Minus in this one. Now we're just going to take and multiply those for that middle term. And then 3 squared is 9, so that goes there. Okay, so these are sum and difference of two cubes. All right. Again, I'm not going to test you on it, quiz you on any of that stuff. But I'm mentioning it. You should probably do a couple of them. And then you should be okay. All right. It's just not a big part of factoring that like the other things are. Okay. All right, let's go back to doing some more of these factoring problems here. Let's do I want to change this one a little bit. Okay, let's try this one out, see where this one goes. So what can we do with this one?
Take the 2 out.
And let's see, we're left with y squared plus
8.
minus 16. Okay. All right, what are we left with inside?
Well, it's not a difference of 2 squared,
Nope.
but it is a transcendent.
Yep.
But last time you said because it's only 2y, that I don't need to do the AC method,
Yep.
so I don't know what needs to go next.
So wouldn't it be y's inside in both parentheses?
Yep.
And then somehow it's going to be 4's.
Yeah, because you have factors of 16, right?
Yeah.
So let's see what we have. So we have 16, 1, 2 and 8, 4 and 4. Are any of those going to get us the 8 that we need?
2 and 8 and 4 and 4.
The 4 and 4 will?
If the other one's not, which would be negative 8.
This is a minus, right? So what do we have to do with these two to get this term?
No, because 2 negative equals positive.
Why are we writing this here?
Oh, is it 6 and 3 then?
Oh, we're backing up here. Why are we writing this? What's the purpose for that? Why do I put it there?
Because it's negative.
Not because it's negative, but it tells me what. Somebody said it too.
They need to subtract.
That's right. Someone subtract, right? Okay. I know that whatever I do here, I want to subtract these to get that middle one. Okay, so 16 minus 1, that gives 8.
No.
2 minus 8,
No.
4 minus 4. Oh. So, can we factor this thing inside here? Nope. There's your answer. So make sure you understand why we're putting that there. Yeah, it's a negative, all right, but it's also telling you whether you're going to add or subtract, okay? Because some of these you're only going to have one step, and that's it. So you got to be careful. It looks like it factors. but it doesn't. Okay, factoring completely still. Here's another one. X to the fourth minus 16. Well, can we take anything out? No? Okay. What's the next thing? Is it a difference of two squares? Yeah? Oh, awesome. So factor it for me then. What's it going to be? X squared minus 4, x squared plus 4. Okay. Is it done? Who says no? Why?
Because you guys still perfect squares.
Because we got another difference of two squares, huh? Yep. Good call. Okay, so what are we going to factor that down to? X
Plus 2, x minus 2,
x minus 2 what?
plus 2.
And okay, can the x squared plus 4 be factored?
Yeah.
You can? What are you going to factor it to?
Wait, you can't.
You can't.
Because of the addition sign.
That's right. The addition sign. Yeah, that's done. That was good. Charlotte caught that. All right, good deal. Let's see. On 458, are we doing anything high? What's the highest number problem we do there? Yeah, 450. Which one?
85.
85. Okay. All right, so look at 458. Let's do this. Let's look at it. I don't know which ones you have to do, but are there any on there that you're just looking at right now and have don't even want to, I mean, you're not sure how we would start it? And don't, if you see something at all, say it.
69.
Which one? Whether it's on our assignment or not, doesn't matter. Just say it. 69. Okay.
Can you do the, oh no,
So let's go through our list. Can we take anything out?
Nope.
Nope. Is it a difference of two squares? No. Is it a trinomial? No. What's left? What's left on our list? Grouping. Let's try that. Group the first two. Group the last two. Let's see if it works. Okay. What can we take out of the first two? Leaves us with 2y plus 3. Okay? What about the second one? What can we take out of that?
25.
Now that's a minus, so this has got to be a minus also, right? What are we left with?
2 minus 3, plus 3.
Hey, how about that? It is a grouping one. So what's the answer here?
2y plus 3 and then y squared minus 25.
Okay. And that's done? One vote for yes.
Yep.
3 votes for yes.
Oh, it's a perfect square on the bottom. Yeah. So it's 6.
Okay. So what do we get here for an answer then? Uh-huh. And?
Y plus 5.
Yep. Shall figure that out. She caught 2 of those now. Maybe everybody's going to be sending their stuff to you for you to proofread it and see if there's any difference of 2 squares on there. Okay, any more? That was a fun one. Good choice.
74.
Oh, man. Looks pretty intimidating. Y to the 9th minus y to the 5. Okay. Can you take something out? Great. Y5 comes out. Leaves us with y to the 4th. Minus 1. Okay. Is it done? Well, what's left? Difference of 2 squares. Good. So what's that going to factor down to? Y squared plus 1, y squared minus 1, y to the 5th outside. Is that one done? No. Why not? Y squared minus 1's there. So what's that going to factor down to? Y plus 1, y minus 1. Good. Oh boy. There's another good one. See? You're picking out some good ones here. These ones are going to take a little bit, you got to be careful and make sure you're looking at them. Don't go too fast. Okay? And that's, on the test, it's just going to say factor them, so you're going to have to check every single one you do. All right? Might take 1 step, might take 3. All right? That's how it's going to have to be. Yeah, do whatever you want. What does that one say?
That one is 3r cubed minus 27r squared minus 210r.
Okay? What do you want to do on that one? Can we take anything out?
3.
3? 3r? Okay, what are we left with? R squared minus 9 R minus 7D. Good. Okay. Got the 3R out of there. Now what are we left with inside?
R squared minus.
Well, first of all, what is it, just so we know? Trinomial, right? Because if not a difference, 2 squares. I think it's good that you'll be able to check that list and know what you're looking for. So it's trinomial. So go ahead, Paul. What are you saying we're going to do with it? You had it figured out?
I know the answer is going to be R.
Yeah, we know we're going to have R's. We just got to find factors of 70, right?
Yeah.
Okay, let's see. This is 2 and 35. I know 7 and 10 are going to go in there. I know 5's going to go in there. Yeah, here I can do double and half here. So I can go 14 and I can go 5. Double and half.
It's going to be 14 and 5.
Yep. So we're going to have R minus
14 plus 5.
and r plus 5, and the 3r goes out in front. No difference of two squares on that one, we're done. Good.
So I have a question with the guessing. Do you want us to have that little chart on the side?
You know, that's up to you. I keep saying this. You got to do what makes you can get the problem right. Okay. Now, the guy last week did that little X thing. If that works for you, then use that. If this works for you, use that. If you've got something else that's working for you, then no, you do whatever works for you. You might be able to find the factors without even doing that, right? But you just got to, the big thing is making sure you understand that are these going to subtract that number or are they going to add to that number? Right.
Okay.
So if you keep track of all that stuff, you get them right, go for it.
Okay.
Okay. I'm not going to ask for anything other. I'm just going to say it's factored completely, and you can do whatever you want. Any more on there? Okay, I'm going to show you one more thing, and I'm going to give you some time to work on some stuff here. This is a 6.6, which is the last part of this. All right. And it really isn't any different than what we've been doing. So it's not like we're adding a whole lot more to our plate here. All right. We'll change the color though. Okay, so this is the last stuff in 6. Solving quadratics, I guess I'm going to call it. Okay, so basically we're going to look at this. Okay, so this here, yes, it's a trinomial, but because it has a power or a degree of 2, we call it a quadratic. I don't know why we call it a quadratic when quad means 4, but that's what it's called. Okay, it could come from the idea of a square with 4 sides, but we're going to call these quadratics. Whenever you solve a quadratic, you always have to set it equal to 0. Must be set equal to 0. All right, got to. Every single time. Always set them equal to 0. And in the last chapter that we do in this class, we'll look at another way of solving these. But in this one, they introduce something called the zero product property. And this is what the zero product property says. If I have two quantities, say A and B, and I multiply them, and they're set equal to 0, so if I have this, then one of two things is true. Either A equals 0 or B equals 0. That's what the zero product property says. So if I have two quantities, A and B, and I multiply them, and I set it equal to 0, then either A is 0 or B is 0. Okay? And it makes sense because the only way I'm ever going to multiply and get a 0 is if one of those two numbers is 0. Right? Because 0 times anything is 0. But it could be A or it could be B. Now, how do we use that? So let's say we're going to solve this equation. and it's written in what we say factored form. So it's written in that factored form like that. The only difference is now I have equal to 0. So the zero product property says either x plus 3 is equal to 0, and I forget about this one, or x minus 2 is equal to 0, and I forget about that one. Because it doesn't matter, one of those has got to be equal to 0. So I would say, all right, if this is equal to 0, then x has to be negative 3. For either because negative 3 plus 3 is 0, or I could subtract 3 to both sides, whatever. If this is equal to 0, then x would have to be equal to 2. Again, either 2 minus 2 is 0, or I would add 2 to both sides to get it. So these are my answers. Negative 3 or 2. All right? Negative 3 or 2. Those are going to be my answers. So the zero product property says, again, either this is going to be 0 or that's going to be 0. So our objective is to take a quadratic and get it into factored form and use the zero product property. Okay, so that's what our objective is. But we know how to do that because we can factor stuff, right? So we just have to factor things and get them into the right form, and we're in great shape. Now the first couple of problems you're going to do are going to be all just like this. So they're going to have like an x plus 5, and they're already going to be factored like this. They're going to be already set equal to 0. So all you got to do is put down the answer. Now there's a real easy way to come up with the answer to these, because you want to set them equal to 0. Notice here, because x plus 3, what was the answer? Yeah, so it's just the opposite. All right?
I know that it's the opposite, but going back to the first one, how do I know it's negative?
Well, what negative 3 plus 3, if I put negative 3 in for x, negative 3...
Oh, then again, negative 3 plus 3 equals 0.
Right. And the same thing for the other one. So really all we need to do is put down the opposites of what's inside here. So negative 5 and 4. That's it. That's all we got to do. All right. You can write it. Yeah, well, okay. You should be able to just go like we did on the second one there. Right? It's just the opposites, right? Yeah, there's no reason to show any extra work there. Now, these can switch around a little bit. So, for example, we might have something like this. Okay, so things might change a little, but the whole idea is the same. So, what's one of the answers right away? You should be able to see it. Negative 1. Okay, and Paul says, what was the other answer? 0. Because what's being added to this thing right here? 0. Nothing. So it's just 0. So there's our other answer. Negative 1 and 0. Okay? Those are our two answers. We might have something like this. 2x minus 1 and 3x plus 4. Alright? These ones are a little trickier. But the idea is kind of still the same. We're going to take the opposite of this negative 1. What's the opposite of this negative 1 that we have right here? 1. So I'm going to put a 1 there. The only thing is, if I was to solve this out, all right, and I wouldn't recommend doing this because it takes too long, my final step is to divide by that 2, correct? So I'm still going to take the opposite here. Right here, still going to take the opposite. And then we're going to divide by that number. And before we didn't have to divide by that number because it was just 1. So there's one answer. Now using that same idea, what's the answer going to be for this one? Negative 4 over 3, yeah. Right? Because we're taking the opposite and dividing. There we are. All right. Okay, so now let's take it a step further. So let's do this. So now we're going to go x squared minus 4x equals 0. And we're solving these. So we're actually going to get an answer. So we're solving these out. Okay, I'm going to go right down my factoring things, just like I did with all the other ones. Not changing a thing. What's the first thing on my factoring list? Taking something out. Can we take something out of this? Take an x out. X comes out. What are we left with? X minus 4 equals 0. Okay, now I can do this. So what's my answers? 0 and 4. So all we're doing is taking it one more little step. What we're solving now, we're just using factoring as a technique to get there. Do you see how we factored it to x times x minus 4? So then you're just taking the opposite, right? That because we want it to be 0. Okay, how about this one? X squared minus 64. Can we take something out? Okay, difference of two squares. What's it going to factor to? So we're going to have x so that means the answers are, yeah, and the way you can write that is just go plus or minus 8 like that. Okay, plus or minus 8, that's what that means there. Okay. Can we take anything out? No? Difference of two squares? Difference of two squares? How many terms? It's trinomial, right? 3 terms, right? Yeah. Okay. All right. AC method, guess method? Really? Is there a number in front of the x squared? No, use the AC method then. Don't use it with there's nothing in front there. It's a waste of your time. Okay? No, we're just going to factor it. Remember, these are the ones that were in 6.2, and I said, oh, these are easy ones, right? You guys said, oh, yeah. Okay? If there's nothing in front of that x squared, just factor it. Straight up, trinomial. Okay, don't use the AC method. Just, hey, I'm going to take factors of 28, Find the ones that work and go for it. 2 and 14, yep. Okay, what are the ones I need? Good. Let's see. Which one's minus, which one's plus? Nice. Okay, what's the answer? 14, -2. All we're doing is taking it one step farther. It's going to be the opposite. X squared plus 10 I'm actually going to make this one a little different here. And I want to change this a little bit. Equals -10. That's what I want. Okay. Yep. Okay. Can we factor this one the way it is? What was the first thing we said about solving quadratics? Absolutely has to happen.
It has to be 0.
Yep. So we got to add this 10 over to this side. You cannot factor these unless they're equal to 0. And the author of this book, has something like that. Okay? So you're zipping along and all of a sudden he's got equals and it's not equal to 0. You got to make it equal to 0. Okay? Now you can factor it. Okay, so let's see, we're going to use the, what do you want to do to factor this, by the way? AC method or? Man, I can't talk into that guess method, huh? Okay. Alright, any of those work? 30 and 1. Here we go. 3x squared. What are we going to write next? Plus 30x plus x plus 10 equals 0. What can we take out of the first one? 3x. That gives us x plus 10. And what about the other one? Ooh, jumped the gun a little bit there. What can we take out of that? 1. X plus 10 equals 0. Put it together. 3x plus 1. X plus 10 equals 0. You're all happy because you're done, but you got to remember to solve it. -1. Oh, that's not -1. -1/3 and -10. Yep. Okay. Good deal. So that is all of chapter 6 right there. All right. The solving ones are the last things we do in that. So, let's see.